Thank you very much for inviting me today in the presentation. We are XKELET. We create immobilizations personalized for each patient. I will give you to the jury. I will go very fast because we don't have time. So we have the certifications, FDA approvals, European Commissions, and ISOs and everything. We are going to explain more faster than the presentation because we don't have time. So about the product, we solve more or less the 95% of the problematics of the real, right now, actual immobilization systems, plasters, orthotic, thermoplastics, wherever. Okay. What we create that? We have a software, intelligence artificial, who creates that and to give us the opportunity to make the less price in each product unit. So doesn't intervene any kind of human activity in the construction because we scan and automatically our artificial intelligence software construct the immobilization. All the process is between 40 seconds. So after this 40 seconds, it's going to send directly to print. Okay. We print with different kind of technologies. One of the most famous technologies is FDM, for sure. We take 8 hours max time to print in FDM, but right now we are going to present in Fromnex a new technology to print. We will be able to print 30 centimeters tall immobilization in more or less 30 minutes. Okay, and this will be more or less all kind of our process. It's product, it's software, it's an intelligence artificial system, and last product printing. With all the product we are talking about to try to substitute the normal products that we have in the market in price also, because we can compete with the price with plaster in this case. So the final product, without taking the profit, we can compete with the final product. So that makes this product real. Right now we have distributors in Colombia, Mexico, we are working in Brazil, we have distributor in United States, and we are working with Middle East and other kind of distributors we are working right now, and we are start selling in Colombia and Mexico. Okay, and well, thank you for the presentation. And if you want, I can who controls the screen? You can pitch the YouTube channel, the icon, please. You cannot pitch the icon of the YouTube. Yeah, pitch it, please. It's going to up YouTube. No, it's not okay. Okay, you cannot show you the video, but well, more or less in a big resume and faster resume is what we are doing. Thank you for your time. Questions?
Thank you for your presentation. Can you just summarize, given the fact there's many 3D printing exoskeleton type of companies in the world, what is actually your pitch around your product differentiation? What is the actual solution? I understand that there's a lack of IP as patents. It's a complicated space, but what is differentiating you?
First of all, we have to say we have the certifications, FDA, MMPAs, all European Commission approvals, the class 1 product. After that, we have patent in United States and all Europe about process, design, and everything. So we have the patent of every kind of product have to scan and create an immobilization. We have this system patent. And also we have the closer system patent and the design patent. This is one in one hand. But the best main goal that we have is the software, because we have the very good final product with red dot design, so it's tested with different kind of patients. It's working in the market, but the final the core business of the company, the software, it's what gives this product real in the market, because you cannot give or tell to a doctor or trauma they said to spend more time to creating something what usually they're using right now system. So it's just to take a little iPad with little scan and take 1 minute to make the whole process without any kind of error, human error, because everything is artificial intelligence. We take the scan, we read all the arm, the leg, wherever. Right now we are working with arms. We are going to go farther in this in this next year about all the other upper and lower extremities. And after that, it's the printing process. No one right now can serve a product in 8 hours. It's max time for us. And we are going to give the product in 30 seconds in 2-3 months. 30 minutes. Okay, so I think we have a lot of main goals. At the end of the things, if you can imagine, we can scan and construct wherever we want because we have artificial intelligence. We can do that, and I don't say that. MIT say that, Mitsubishi say that, Apple say that. Okay, so this is what I think our goals are, artificial goals.
Yes, hello. I have a question about the clinical feasibility and the convenience for the patient of the system. Clearly you have... Hello? Now yes. Yeah, a question about the clinical feasibility and the convenience for the patient. Clearly this 30-minute window, time window that you have is much better than the earlier 8-hour window, isn't it? But does this mean, because the patient can't wait for 8 hours to be immobilized, and once you have the traditional cast, it is less convenient to, no, it's okay, thank you. It's less convenient to, for the patient, isn't it? So does this mean that the hospitals will have the 3D printer? Every hospital will have one?
Hello. Okay. In my experience, for sure, time it's a handicap. Okay, but we can solve that in different ways. One of the ways is to create faster printing process. Okay, but we have other ways. We are talking about immobilization. Or immobilization can cover all the other kind of injuries that you can get, as big fractures with displacement, as chronic pathologies, deformation process. Sometimes people need to use for 3 hours a day, or different kind of pathologies. Okay, so in the urgency solution, in the emergency room, yeah, for sure, time is very important. For the other ones, it's orthotic. That's not problem. It's the same time that they are working, or more. The normal orthotics takes maybe 1 day or half a day to give you the prosthetic. Okay, we are working also in emergency solution. Emergency solution means to create some previous immobilization after to use XKELET, but not it just for time. It's just to resolve a problematic about the trauma needs to redirect the fracture. So and also you have a swallow. So if I scan right at this time and I put a skeleton, we go the same errors that plasters has. After 1 day you have a lot of movement inside, so you're not going to fix. So what we are doing is create something we can print with FDM in 20 minutes, something like that, very cheap for emergency room to use 5 to 10 days previous after to use XKELET. With this solution, it's not a problem to wait 8 hours after later on.
To do well, then the answer is no. There won't be a 3D printer at the emergency room. Is that the answer?
No. They will need a 3D printing room. I think our focus goal is all the solutions have to be in place in every kind of hospital, every kind of emergency room, and every kind of orthotic. But we know this is a process. So big hospitals who can get the amortization machine and all the process, they will be able to do that. And in the future, I hope in all the hospitals they will need to use this system, because right now we are making immobilizations, but we can use the printers to make other kind of things, not just immobilizations. So right now we are working to different kind of business models. One of the business models is put everything in place. Another business model is put the iPads and the scanners in place, and we get these production centers who distribute faster delivery to the centers. Thank you very much.